57, I was thought that was not copy. Oh, I mean, all I got in there is like paper.
I'll give you some.
Oh, I think it's something.
Here's the. There's also paper here.
All right, thank you.
I first want to.
It's not that sharp, but yeah.
Appreciate it.
First, I want to address a question that was asked right before class. If I have a position versus time graph, how would I find velocity?
By looking at the vertical movement, because that's the change in position.
No, there's more to it than that. So if I've got that and that, say there's two different objects.
Look at the slope.
In fact, we can highlight that by having a different color here. We'll call it object 1 and object 2. Which one's traveling faster?
One.
Okay. We can look at it from one point of view, the fact that in the same amount of time, one travels a greater distance, has a greater displacement. What else can you tell me mathematically about the difference between 1 and 2?
The slope.
Okay. So if you have a position versus time graph, how would you find velocity?
Slope.
Yes. Good. I'll just do shorthand. This is velocity. If something is getting faster, what would you expect to happen to the slope?
It gets
Steeper.
steeper.
I heard two things at once, missed them both.
Same thing, steeper. They got steeper.
It got steeper.
Yeah.
Okay. So if I had that and that, which one what can you tell me about the change in velocity here and the change in velocity here?
One is exponentially increasing, and the other is
By the way,
exponentially
like one has 1 and 2.
decreasing.
Are they both speeding up?
Yeah.
Yes.
Okay, they are indeed. What can you tell me about the acceleration of this one?
It's more constant. Or
Is the acceleration plus, minus, or 0?
plus.
Okay. The acceleration here?
Negative.
Okay. How do you know?
Because the position is going down. It's going negative.
No, it should be positive acceleration.
Why?
What is it?
Because it is something to do with like the velocity is negative. It doesn't
Yeah,
matter if
it-
the velocity is
yeah.
negative or positive, as long as the velocity is increasing, the acceleration is increasing. But, I mean, in that example, I mean,
The velocity is negative, but the acceleration is positive.
yeah,
So if acceleration is positive, velocity is negative, that means the velocity is changing with positive change. If acceleration is positive, the change in velocity is positive. If we go back to acceleration, is the change in velocity over the change in time. These are the only two vectors. This change in velocity and acceleration are the only two vectors. If this is positive, that's positive. If this is negative, that's negative. I'm assuming we're not going backwards in time.
yeah,
So,
Oh, yeah.
okay.
Yeah.
if acceleration is positive, the change in velocity is positive. That was, I guess, my most recent question. Question mark. So you're saying that there's a positive change in the velocity here? Is that what you were saying?
A negative change.
A negative change in velocity. So you're saying acceleration is negative here?
Velocity
negative.
is too. And velocity too, right?
Wait, no.
Velocity is negative,
And it's speeding up,
yes?
so acceleration should be negative, right?
Yeah, and why?
Well, it's getting faster, so,
There are a couple different approaches, so just, I'm trying to figure out how you've come upon this conclusion.
well, the object two is speeding up, and that means the object's gonna have to be accelerating, and velocity is already going that direction, so I figured they were both negative.
Okay. So one way to look, I mean, that's spot on. Also, if it's speeding up, acceleration and velocity, the same sign. In order to get faster going in the negative direction, it has to be pushed in the negative direction, and that force and acceleration will be in the same direction. Or, looking at it from this point of view, I have some negative slope right there. And I have a more negative slope there. So it's becoming more negative. So velocities has a negative change, and therefore acceleration is negative. Both of these are speeding up. Just this is speeding up in the positive direction, that's speeding up in the negative direction. If I have a velocity time graph, how do I find acceleration?
The slope.
Yeah. So slope of velocity versus time is acceleration. So what can you tell me about the acceleration of this object?
It is constant.
Okay.
Or actually, no, it is 0. No, it's constant, not 0.
A constant, not zero.
Constantly positive.
Yeah.
There we go, we added that
Sorry.
extra bit, yes. Assuming that I drew that straight, it would be constantly positive. This one right here,
0.
0.
and this one,
Constantly negative.
all right. In this first region, it is speeding up, because if this is 0 right here, I'm getting farther away from 0, which means I'm speeding up. So I'm speeding up, my acceleration is positive, my velocity is positive. It matches what we'd said before. In this region right here, I'm slowing down because I'm getting closer to 0. My velocity is positive because I'm above the axis. My acceleration is negative because the slope is negative. So I'm slowing down, I hit 0, and then I start going in the other direction. Now, some of this is just a repeat of stuff we've done it before, or a couple of it is, in theory. But I at least wanted to address, I know I answered your question before, but I just wanted to flesh it out just a little bit.
But like, kind of like what I was trying to get at was like if, like on the number 3, it's like it starts slow and it starts to speed up, but then if it's not constant, then how would I like determine the velocity, the change in velocity?
All
If
right,
it's
so
not constant.
it turns out when you're talking about, I've got position. So if I have position, velocity, acceleration, jerk, snap, crackle, pop. If I'm going in this direction, so from a position time graph, I find the velocity graph. From that, I find the acceleration graph, find the jerk graph, and so on. It turns out that I'm gonna decrease the polynomial by 1 every time. So if this is say something times 10 to the 5th, this will be something times 10 to the 4th, that'll be 10 to the 3rd, 10 squared, 10 to the 1st. That'll be just some constant. that would be 0. In the case where what you drew, or what I sort of drew over, let's say right here,
Yeah.
it's sort of was kind of like a parabola. So if that's a second order, so that's 10 to the second, not 10 to the, it should be x. Wow. That's 100. X to the 5th, x to the 4th, x to the 3rd, x to the 0. So parabola is x squared, it's something x squared. So my velocity is gonna be something times x to the first, which is a line. And then acceleration will be x to the 0, or it'll just be a constant. 1 times some number. This would be x times some number, the slope. This is x squared times some number, which turns out is half the acceleration. I don't know if I answered your question or not, but it was an attempt at it. Stone, you want to ask your question again? Or did I answer it?
Yeah, I got the, well, I kind of knew that already just from like calculus
Right.
and derivatives, but I would think like for like position, if it like speeds up at a constant rate, then the velocity would be a line. But then like my question was, what if it's like speeding up at like an exponential rate?
So not x cubed, but more like 2 to the x.
Oh, yeah, I guess so. Yeah.
If it's a 2 to the x, then it's still, from calculus, you would take a derivative. In physics 151, where calculus is not required, what I would hope that you would do is you would, so this is, that's x at time, x is equal to 2 raised to the t power.
Let me.
You would, from a calculus point of view, take the derivative with respect to time to get the velocity, take the derivative of that with respect to time to get the acceleration. From a physics 151 point of view, sketch it out, find the point where you're trying to figure out what the velocity is. Take the slope. Or if this is velocity versus time, calculus, take the derivative to get acceleration, integrate to get the displacement. To find the acceleration, take the slope at some particular point. And to find the displacement, you'll have to somehow estimate what that area is. When you're dealing with non-constant acceleration, and with non-constant acceleration, it really has to be done graphically without calculus. Dominic?
If we're trying to find, like, let's say we're trying to find velocity from a acceleration time graph, we use antiderivatives.
Yeah, well, except the antiderivative, what that's gonna find, or the area under the curve, what that would find is the change in velocity.
Right.
You would need some initial condition in order to figure out what the velocity is. All right, so for those who have not had calculus, if you hear integral or antiderivative, those mean the same things. At least from a physics point of view, there might be some math picky thing, a difference between the two. And from a graphing point of view, all that the integral does is it finds the area under the curve. So if I did the antiderivative of this function from 0 to here, all I'm doing is just finding that area right there. If you had calculus, you're just doing an integral, but realize that the area under velocity versus time is displacement. Area under acceleration versus time is change in velocity. follow-up questions or reworded questions or other questions? Okay. Let me give one problem here, and then we'll put a stake in the heart of chapter 2. All right, a ball is thrown upwards from the top of a 20-meter tall cliff on Earth 2 at 35 meters per second. At what time is the ball hitting the bottom of the cliff? That's basically the scenario right there. You're right at the edge of the, I guess I should say at the edge of the cliff, not just the top of the cliff, but edge of the cliff, throws it up, comes down, hits below. I know that, is it 20 meter tall? This is 20 meters. This is initially going 35 meters per second upwards. And I'm trying to figure out the time at the bottom. As with any of these problems, we got the 5 basic quantities. So I'm just gonna sort of set up my chart here. So delta x, v initial, v final, acceleration, and time. What do we know?
Initial velocity,
Is
35 meters per second.
what assumption did you make?
That it is, the ball goes at 35 meters per second, the second it leaves the hand.
Okay, at the moment it leaves the hand.
Yeah.
They've made another assumption.
Positive. That's positive.
More specifically,
We're going upward.
yeah, that upward is positive. So by making that positive, is established up is positive.
Yeah.
It will affect the rest of the problem. Okay. What else do we know?
Displacement
Is
would be 0? Would it be 0 or?
from where it begins to where it ends.
Oh, then. Never mind.
Dominic?
Displacement would be 20 meters?
Yep.
You know, it's from the starting point, correct?
Yep.
Well, it passes through the starting point
Yep.
twice. It starts and then goes through.
All right, we'll put down 20 meters and,
Negative 20. Right?
yeah, there we go.
Okay.
It does end up lower than it started. If you say 20 meters, you are then gonna be solving at what point is it up here
Mm-hmm.
and not down here. All right, we have one other thing that is given, or understood to be given.
Acceleration is, negative 1.8 meters per second.
All right, except for the fact we're on Earth 2,
Okay.
which I guess I haven't
Oh.
defined yet, or have I?
No.
I didn't see Earth too.
What is Earth 2? What's the acceleration of gravity on Earth 2? I guess I haven't given that yet. If I say Earth 2, 10 meters per second squared, we're just basically, it's close enough to our Earth, and just to make the math a little bit easier. So you said negative 10 meters per second squared. If you made the acceleration positive, then you're throwing it upwards. It's accelerating in the same direction as the velocity, so it's just going to get faster and faster as it goes up. And so what you should end up with, if your displacement is negative 20, is you should end up with something that makes no sense. So if this were positive, and this is positive, and that's negative, you'll end up with some bizarre answer. If you made everything positive, then you have the thing speeding up as it goes up, and you're figuring out how much time does it take to get to the very top. Or you're establishing, you're throwing it downwards at 35 meters per second, how long does it take to get to the bottom? Comes down to, if the answer doesn't make sense, check your signs. All right, it is constant acceleration problem. We are ignoring air resistance as usual. What are the four cake formulas? It'd be nice if people could do it without looking, but if you have to look.
VF equals VI plus AT.
I think that's what you said.
Yes.
There's one. Does not have to be in the same order in which we derive them.